Hey, I'm Joe Berlew from Advanced Manufacturing here at MTC. I'd like to take you on a short but real informational visit to what we do here in engineering. As you can see behind us, we have a group of students that are working in automation and manufacturing. They're working with robots and sensors and all this different equipment. And you can see that all of this stuff is totally autonomous. They have it all programmed into the software. So Joanna, tell me what you have going on.
I have the collaborative robot that allows people to work alongside a robot with the safety guard in the front. I programmed it to pick and place that stock from this X onto the conveyor belt that moves it to the FANUC robot.
I'm running the FANUC today. My name is Ryan. I'm doing a simple pick and place procedure. Compared to the collaborative robots, the FANUC is less friendly to people. It doesn't really have any true safety mechanisms in place, but my procedure is pretty easy. I just move from this conveyor to that conveyor.
My name is Marco. I programmed the conveyor to move to the UR3 robot, do a pick and place procedure. From there, it will be running on the linear slide base to move it down to that red indicator down there. And from there, Eli will pick it up with his robot and move it into the gravel tank.
So just like Marco said, the linear slide base will bring over that block, put it down in that red indicator where my robot will then go ahead and pick it up and put it inside the Gravitron. So robot's already pre-programmed to go ahead, knows exactly where the block is, pick it up, move it inside the vice grip inside there. And once the block has been placed inside the vice grip will then close along with the door. And it stops.
So next thing I want to show you is here we have a new CNC mill and we have a new CNC lathe. And these are pretty cool technologies. We're integrating what we're doing here in the machining. We have Vince, who's a national champion in 5-axis milling. He's one of the only first place winners at the national level. And he's doing an outstanding job. So Vince, tell us what you have going on here with these coins.
So right now we have a NASA logo program loaded. So that's going to engrave the NASA logo in the back on the top side of this workpiece. So as soon as I hit cycle start, it's going to pull up the program and then start engraving.
Looks like you're doing a great job there, man. Looks like you're doing a great job. Doing that well. So, in reality, what we're looking at is a coin like this. We're making our own medallions, and each student makes his own medallion, which is pretty cool. We have a 2.5-inch diameter piece of stock. We cut it on the horizontal bandsaw. We bring it in here, we put it in tool 1, comes in and faces the whole operation off, and then we do the engraving at the end for the finished pass. So, come on by and I'll show you some other cool stuff that's going on here. Nice job, guys. Good job. Good job. All of our students have done all this programming on their own, and everything that you see around here is totally autonomous, and they've done all the wiring, they've put on the sensors, they put on every distance sensor, and as you can see, each one of these things have their own purpose and each of their own functions. And what do you have going on here? What?
I'm just messing around with the VFD for low frequency drive and the PLC programmable logic control.
Cool, cool. So you learn about PLCs and VFDs in here. That's really cool. What are you running?
I'm just trying to run the VFD to spin this. I put it in 60 hertz there, and then I turn it on.
Oh, so it doesn't really run off RPMs, it runs on hertz. That's interesting. Looks like it's running pretty good, man. You're doing a great job. What are those little sensors over there for? What does that do?
This is a proximity sensor. It
Right.
triggers whenever something's in front of it. This is an inductive sensor, so if I put my piece in front of it, it'll trigger. And this is a...
Okay, what if you hit that E-stop right now?
It just turns off.
Wow, immediately goes on to this HMI, and it tells you that there's been a problem. So one of the cool things about here at MTC is Advanced Manufacturing. We do several different products, and everything that you see around you is made here. I mean, even with this area right here, you can see all these beautiful products that students have done. Everything that you see here, students have made. Hey, Don just came out of the 3D studio. So Don, tell us what you got going on.
Well, I'm here using my GI Bill, taking advanced manufacturing, and I've learned how to use the 3D printers where you can design and create different parts using different types of 3D printers. This part is a gear for a monster truck, and then these encoders, this is the original, and then this is the one we made here in the studio, and it's being actually used on the robots you see behind you. If you step on into the studio, I'll show you what we got going on. And over in this computer, one of the students wanted to learn and try to create an airplane. So we're doing a prototyping process to see how it's going to come out, and it's going to be in multiple pieces. On the other computer, we made a bushing for one of the administrators in electrical so he can purchase bigger spools to allow it to rotate freely and be supported. Over here, I'm making a print for one of the students who wanted a little character figure. And if you look over here, this is just some of the small things that we have created here in the studio while taking advanced manufacturing.
So as you're coming through the lab, I want you to see we have all kinds of different machines and equipment and whatnot, and everything you see here is made here. So Daryl, he's working in the hydraulics trainer. What do you have going on, buddy?
We have made a closed loop system using the hydraulics here, and as you can see behind me, I have made multiple little gizmos controllable through the directional control and one valve. I can use that valve to control the speed of the motor here, and I can use this to control the direction of this piston. Let me turn it on for you right now. And with this pressure regulator, I can even control the speed and the power behind it. But first I gotta open it up.
There you go. How many PSIs does it take to compress that spring?
About 400.
About 400. Wow. That's a pretty heavy duty power there.
That spring does not want to move.
That's good, man. That's
And with this valve, I can control the speed of this little motor.
That's cool. And the DCV stands for what?
DCV, directional control valve.
Very good, Daryl. Very good. Hey, let's see what Yapsum's got going on over here. Yapsum, tell me what you got going on, man.
All right, so we've got the simulation of a AC wiring of a typical household in America. We have power coming in into the GFI, supplying this switch, which supplies this LED light bulb. Also, we have over here this Bluetooth enabled speaker and light bulb. Change the color. And
So you're telling me that's all Bluetooth?
yeah, that's
Can
all.
you change the light color?
Yeah, you can change the light color using this remote.
That's cool. I don't think, is this something you learned on your own, or is this something you learned here at MTC?
This was taught at MTC's advanced manufacturing class.
And you're doing a great job, bro. You guys are doing a super job. All right, so really I want you to see some really unique stuff too. The students have made several different products, but you can see that this one happens to be a guitar. I don't know if it's a Gibson's or what, Fender or whatever it might be, but this component right here was made on a CNC router. So we do routering, and this is what's called 3D routering. This is 2D routering. You see, this has a third dimension because it has an X and a Y, and the depth becomes Z. This is 2D because basically it's just on the X and Y. And we take a milling bit and go here and mill this out, and it's all machined without any human intervention except for the work that we do on the front end where we design, create, and build. If you look real close, you can see there's a lot of 3D stuff going on in that depiction of a sea life. And we can pretty much do anything. And as far as I'm concerned, yesterday one of the students made, what is this here, Vince?
Han Solo and Carbonite from Star Wars. So basically he got the Empire angry at him and they encased him in Carbonite. And if I hit single start, this is the finishing pass for that specific project. So this is just running through the lines of code that define the finishing operation on this.
So we do two basic passes. We do a rough pass and we do a finish pass using different mills. And it's kind of unique because all these students are learning these skills right here at MTC. And honestly, it's been a blessing to have such great students year after year. I'm really excited about the administration, our whole department, and everything that we have going on. There's a lot of great courses here at MTC. But let's see what's happening next. What do you guys got going on here? Looks like a lot happening here. What is going on, Jordan?
This is some of the stuff we made here on the plasma cutter right here, and it's all stuff that I never thought I'd ever be able to make before I took this class.
And basically what a plasma cutter is, it's basically a tornado with a lightning bolt in the middle. And we're about to cut a Spider-Man symbol on an 1/8" aluminum. And my friend Pedro over here is about to run the machine for you.
So you're telling me that that could cut through 1/8" metal?
Yes, sir.
Okay. And plasma cutter is, what did you say? It was like a...
It was a tornado with a lightning bolt in the middle.
Really?
Yeah.
Interesting. All right, so let's see what you got here. Better call it. All right. Fire in the hole! Fire in the hole! Something. Have you ever dreamed that you could do some stuff like this before? Before coming into the program, did you ever think that this would be possible? No?
Never thought I could run any machines before I came to MTC. Good place to be.
Good, good. I'm going to show you, last thing I want to show you is this over here. And it is, hey, Zach, so what do you got going on over here? Look at what Zach's got going on. This is a laser. Laser is actually an acronym that stands for light amplification for stimulation and emission of radiation. What it does is vaporizes anything in its path. So when you see these cuts that are burnt into this, that's really like a raster cut. And then when you see parts that are cut out, it's really a vector. So Zach, how you doing, bro?
I'm good.
What kind of programs are you running on here?
Right now I'm running Aspire and Photograve. This is a Photograve of a BMW M5. One of the fastest cars in the world.
And why would you use Photograve as opposed to Aspire in software?
If you want to do a photo instead of like a roster or like a regular photo off the internet, like let's say you want to do a family portrait, you would do Photograve so it gets every single tiny detail, but it uses a bitmap, so it uses dots instead of a solid line to do the photo.
Very cool. Outstanding job, man. Good job presenting. Thank you so much. Again, I want to say thank you for coming on a short but informational visit of what we do here at MTC. Advanced manufacturing, I will tell you that MTC is the place to be. They have a little slogan, it says a career in a year. Well, this course is a half a year, and I can tell you right now, there's a lot of people that are working in careers, and it only took them a half of a year to get there. And I can't thank all of our administration, our great school support staff, everything that we have going on here at MTC and in Manatee County. There's a reason that we have such success at this level. We're standing on the shoulders of a giant, MTC. Gilbert Liu, peace out.